Okay, we are live.
Yep, perfect. Okay, guys. Hi, guys. Good afternoon. Is everyone in? We'll start in like another minute. Just wait for people to join, and if there are anyone else left. Okay, so today we'll be going. I'm introducing you to wireless technology. This is basically a foundation workshop for what Fali is going to do tomorrow. This is just a basics to kind of get you introduced to the basic components of the system and how do we, work around things so that tomorrow it'll be a little easier for you to get up to speed with what Fali has to say. Okay. So, any of you guys have any idea what wireless is all about and what we are going to do today? Simple idea. You can put it in chat to me, or I mean, I would like if you switch on a microphone and then speak to me about it. If you have any idea of what we're going to do today. Have you used wireless before? Any of you guys?
Yes, sir.
Yes,
Okay.
sir.
Can you tell me where?
So over the Bluetooth, Wi-Fi.
Yes. So wireless now this whatever wireless technology that we are going to talk about is not only for pro audio use. The same science applies pretty much anywhere. Whatever you use, your Bluetooth, your Wi-Fi, your phone, your TV remote, everything works on some sort of wireless technology. All right. So we'll be so whatever you kind of see today, the same thing, the same equipment, not exactly the same equipment, but at least the similar kind of equipment is also used in other industries. So your radio industry, any telecommunication industry on satellites, deep space satellites use a similar technology. Of course, it can get very very advanced, and it can get very very simple as well. Okay, so using wireless and audio is just one small part of the entire field of wireless technology. All right, so let us understand what is radio frequency in the first place. All right, so the most basic explanation is radio frequencies are nothing but electromagnetic waves. Okay, you have studied about electromagnetism, right? You might have done it in school. You've probably even done it when you did your microphones class. You know what electromagnetism is, right? Yes or no?
Yes, sir.
Yeah. So the second thing is we as humans cannot hear or feel RF. Okay, that's one reason why it is such a widely used technology. Okay, a light also is some sort of an electromagnetic wave, but that happens at a very very high frequency. That's the reason why we can see it. But radio frequencies are comparatively low in frequency, in the frequency range, so we cannot see it, we cannot feel it, but it travels at the speed of light. All right. Now it can also travel to vacuum. Now don't get confused, but when we say frequency, the term frequency is term to for anything that is cyclic in nature. Okay, so don't get confused between radio frequencies and sound frequencies. They're two different things altogether. Sound, as we know, is changes in air pressure, right? So we'll basically measure how much of air pressure is changing within a amount of certain amount of time. Okay, but radio frequency is electromagnetic in nature, so it can travel through vacuum and it travels at the speed of light. Is that clear? Is there any doubt there? So what we'll be speaking today is all about radio frequencies and nothing about audio per se. Okay, so a simple introduction I can give you is we are taking all the audio and we're putting it onto a radio frequency and we're transmitting it. So that is the only audio we'll be talking about. Everything else is basically radio frequency. Okay, don't get confused between audio and radio here. Sure, all good? Any doubts? If you have any doubt, you can ask. You can put on your microphone and ask me. You can also put it on a
That
chat.
means the sound frequencies. That means the sound frequencies are being converted into electromagnetic frequencies first, and they are then
Yeah, they're not converted into electromagnetic frequencies. There's a way of they're modulated to electromagnetic frequency. Okay, it's basically there is FM, there is AM, and there is those kind of modulations are done for it. So it's not converted. All right. The main difference is that radio frequencies are electromagnetic in nature, and sound frequencies are changes in air pressure, completely different from each other. Okay, sound requires a medium to go from one place to another. Okay, whereas light and any electromagnetic force does not require any medium. It can travel through vacuum as well. All right. Uh, Electromagnetic waves can travel large distances with minimal power. Okay, that's the reason why still RF is used to communicate with deep space satellites. The satellites which have got, if you follow NASA and stuff, whatever satellites they've sent even to the end of the solar system, all is communicating via RF. All right. Now RF can be absorbed, can be reflected like sound frequencies, but of course it depends upon the material. So if we are dealing with metal can reflect RF. Any other material can absorb RF. Okay, like human beings, our skin absorbs RF. Okay, now we'll see how that affects the performance of a system later on. But right now, just keep in mind that metal can reflect RF, and any non-metal surface like wood or human skin, can absorb RF. All right. Another thing you need to keep in mind is the magnetic wave. Electromagnetic wave means magnetism when it is induced due to the flow of electric current. Okay, so if you have an electric current flowing through a conductor, that induces a magnetic field around it, and that magnetic field is perpendicular to the flow of electrical current. All right. And another thing you need to keep in mind is higher the frequency, shorter the wavelength, and that's why smaller the antenna. Lower the frequency, longer the wavelength, that's why you need a longer antenna. Okay, so the smaller the antenna gets, the higher the frequency gets. The larger the antenna gets, the lower the frequency is. Okay, these are few things that you need to keep in mind before we get into actually understanding what the whole scenario with RF is. Is that clear? So this slide will show you, just a graphical representation of how RF and how the electromagnetic field and the propagation of electric current. What are the directions of it? So if you have electric current flowing in one direction, the magnetic field will be perpendicular to it. All right. So for example, I have a belt pack here. Okay. If you can see it, this is the antenna of the belt pack. If the current is flowing through the antenna, the magnetic field is going to be perpendicular. So it's going to go in the x-axis. Is that clear? So if I hold a belt pack this way, the magnetic field is going to be in this direction. Is that clear? Doubts here? See, if you have any doubts, you ask today, because tomorrow, if you don't understand anything today, then it will be a little difficult for you to kind of pick up stuff tomorrow.
Sir?
So, yes.
Sir, can you show that please again?
Yeah.
What is it exactly?
This is a belt pack. This is a belt pack. I'll explain to you what this is later on, but forget the pack right now. Just only look at this antenna. This antenna is in one direction, right?
Yes.
The current is going to flow in this direction. Okay.
Yes.
And the magnetic field is in the perpendicular direction. So if the current is flowing this way, the magnetic field is perpendicular to it. All right.
Yes.
The same principle the same thing happens even in your which microphone?
Yes.
Right? You know what happens
Yes.
to microphones as well, right? Which microphone has the same principle of working, similar principle of working? Electromagnetism. याद है कि नहीं है? So dynamic microphones also work on the principle of electromagnetism, right? But in this case, magnetism is converted into electricity in dynamic microphones. Okay. So once you understand this, now everything kind of gets a little more simpler to understand. So again, we said that radio frequency it's a frequency, it's a wave. Okay, so that wave will have a peak, it will have a trough, it will have a wavelength also. Right, this is common with any kind of wave, doesn't not only audio, even the radio frequencies, any kind of wave that you're measuring, anything that is cyclic in nature will basically can be plotted as a wave, and that wave will have certain properties. You have an amplitude, you have wavelength, you have peaks, and you have troughs. All right, the image below the waveform kind of shows you the spectrum of radio frequency. On the right hand side, it goes into higher, like into infrared and visible light. On the lower side, you can see, low frequency, the mid frequency, high frequency. These again are all radio frequencies. We are not talking about audio frequencies here. All right, keep that in mind. This next slide basically will tell you what are the bands in which radio frequencies work. Okay, we have as for equipment, all the equipment that we have here, all the wireless microphones, the wireless in-ears and stuff, are mostly in the VHF, higher VHF range and lower UHF range. So that VHF stands for very high frequencies, UHF stands for ultra high frequencies. All right. So your TV channels also work in the similar frequency range, by the way. Okay, they also transmitting TV signals at the same frequency range. Your telephone lines are much higher. Okay, sorry, not your mobile phone lines. Your Bluetooth and Wi-Fi is 2.7 gigahertz plus 2.4, 2.7 gigahertz plus. Those are the unlicensed bands, they call them, because those bands are not auctioned to anyone and they are free to use. So most of your Bluetooth technology, your Wi-Fi technology, all that works in those frequencies. You have some microphones also, like a cheaper microphone, wireless microphones, and cheaper wireless systems, basically that use those frequency ranges. But the professional wireless systems which you use in pro audio, we do not use those frequency ranges because that range of frequencies is very busy with Bluetooth and with Wi-Fi and stuff. So if we start using pro audio there, it will be difficult for us to find free frequencies, and we'll have issues with finding a clean frequency to transmit and receive on. So we use another unlicensed band, that is the VHF and UHF band. Now in India, we're using somewhere around 350 megahertz to about 500 megahertz, somewhere in between that. There are some bands which are auctioned off, but there are other free bands that are available for use.
Sir,
yes.
Sir, how do we come to know which band is free or not?
There is a way of getting to know it. First of all, whenever if you want to invest in a wireless system, you need to make sure that you buy the wireless system in the country you're going to use it. So for example, if you are using a wireless system in India, you make sure you buy your system in India. So because the manufacturer is going to make a certain range of products which work in a certain frequency band, and they're going to ship it to that country. Okay. If you're going to use the your whatever wireless device, say your in-ear monitors or your wireless microphones in India, and you go to the US and buy it, it may not work here because of the frequency ranges might be completely different. And those which are available in the US, those frequency ranges might not be available in India. They might have been used by some either government institution or some other mostly governmental based institutions use RF. All right. So I'll show you a way of getting to know which frequency bands are free to use. But right now, with this, you'll understand what the abbreviations are. Your VLF is very low frequencies, LF is low frequencies, MF is mid frequencies, HF is high frequencies, and the ones that we use are very high frequencies and ultra high frequencies. Even in very high frequencies, we don't go to 30 megahertz. We are always somewhere around 300 or 350 megahertz is where all the wireless systems start. And right until I think about 500 or 600 megahertz is where the range is in India for us to use. Now, this is kind of a universal chart that I'm showing you, but in India, we have a certain amount of bands that are available to use. Super high frequency, extremely high frequencies are basically all for telecommunication. Okay. You can see the wavelengths also on the extreme right hand side. The chart, the table has the wavelengths of these frequency ranges. Okay. Any doubts here as to what is RF, how it is? What are the abbreviations and what do you mean by VHF, UHF? I hope you have understood that now.
Sir?
Yes.
Sir, I just read the table, and Why wavelength is decreasing? I don't know.
Because the frequency is getting higher, right? As the frequency gets higher, the wavelength goes down.
Yes.
It's same like audio. Higher frequencies have smaller wavelengths. Lower frequencies have larger wavelengths. Right?
Yeah, sir. Got it.
So that's how it works. The higher the frequency, the shorter the wavelength.
Shorter the wavelength. Yes, sir.
Any other doubts?
No, sir.
All right. So let's now let's understand the brands that are very commonly used in India, Sennheiser and Shure. Both of these are very, very reputed brands. Sennheiser is a German brand, Shure is an American brand. They both make great wireless products and very reliable. So they provide you certain information as to which bands are available in India to use. So I'm just going to quickly go to their sites and show you what they have to say. So for example, if you go to the Sennheiser site, you can all see the screen, right? So it says right here, this is about India. Okay. This is updated on October 2019. And they have whatever series of microphone, whatever wireless devices series they have all mentioned here. And they basically will tell you what frequency, like 100, EW 100s, Evolution 100 series, G4. You can check out. These are the frequencies these are the frequency bands that you'll get it in. You can buy the 100 series G4 microphone or IM system, whatever, in these frequency ranges. Okay, 500 hertz to 516 to 558, 734 to 776. Okay, they have A band, B band, C band, whatever. Okay, then you can go to the 300 series and 500 series. These are a little higher end wireless transmitters and receivers. Yeah, you can go 470 to 558, 718 to 790. Okay, so these are all. This is not specifically for India, but there are certain according to India, they will basically make these. They'll say whatever is made, they'll tune it for these frequencies and they'll send it to you. So now, if you buy, for example, 300 to 500 G4 series here, you can tune it between any of these frequencies, between 718 to 719 megahertz. You can tune these in any of these frequencies here, provided you get a free frequency. Okay. This is the India Monitor series. Okay, you have these. Again, microphone series. These are all EW 100 G3 and 300 500 G3s are these are older models. G4 is a new model which has come out in 2019, if I'm not mistaken. So these are all the updated models. So you can, if you want to buy a system, you can go to the website and see which are the frequency bands that are available in your country and buy according to that. So if you go, say, to Africa or whichever country in Africa, you can go and check out on their site which are the frequency bands that you should be buying there, and just buy those frequency bands. Do not buy anything apart from that, because they won't work otherwise. Yeah, is that clear? Let me show you another one. Okay, can you see this? This is the Shure site. So here again, this is, if you check out here, this is the Shure Accent series. This is Accent analog series. You can check out India here. So India comes under L3 band, 638 to 698 megahertz. Okay. This series of microphones you'll get for India, you need to make sure that the frequencies are these. When you buy the digital system, Accent Digital, you again go look for India right here. 470 to 636. BLX system. BLX is that one that we have here. This is the lower end series, entry level wireless microphones. So they are, again, you'll read here. So these are the frequencies available for India. So you're getting the point. This is extremely important, because if you mismatch the frequencies, your system won't work, and these things are not cheap. Okay, so you'll be spending quite a lot of money, and if they don't work in your country, there's no point. So before buying any system, you make sure that you are buying the right frequency range, especially if you're buying something from abroad. If you're buying something in India, you don't need to worry, because there is a very, very low possibility that you'll get something that does not work in the country. If you still want to double check, you can check the box. You can check the system itself. It will be written somewhere on the system, right? See, if you can, I don't know if you'll be able to read on the camera, but under the BLX, right here, it is mentioned the frequency range is from 518 to 542 megahertz, right here. Okay, this is a receiver for the BLX system. Any doubts?
Sir,
Yes.
uh, according to frequency, the transmitter and receivers are made according to that, or
Yes. The transmitters and receivers all have a frequency range between which they can perform. They can, I mean, so like for example, the BLX system is like a lower frequency range system. I mean, it's a lower system, so it'll have very few bands that can be seen. But as you go higher in the, as you pay more money, you'll get a better frequency range, which is free, and at the same time, you get some more features into the system, which makes it very easy to use. But having said that, yes, the transmitters and receivers are tuned to particular frequencies. Like I cannot take like a Sennheiser series and try to tune it with a Shure, because I mean, the possibilities are less that the BLX system can tune to a frequency that the Sennheiser could tune for. Okay.
yes,
So the transmitter and receiver have to be tuned to the exact same frequency. So for example, if I'm using say 542, for example, 542 megahertz, I have to make sure that my transmitter is at 542 and my receiver also is at 542. Otherwise, they won't connect to each other. Okay.
yes, sir.
Let's check out more. These are all the older series. GLXD is another microphone series. So this is available in the series 2.4 gigahertz. The 2.4 gigahertz is the unlicensed band. So if at all now, whenever you're buying a wireless system, just make sure that you are making an informed choice. Because if you're, say, for example, if you're going in for a system that is not meant for professional use, just meant like maybe for small gatherings, or you're going to use it just in your office or something of that. So then maybe you can go for the higher frequency range, that is 2.4 gigahertz. Now, always when you say higher, doesn't mean it's better. Okay, 2.4 gigahertz and onwards is all taken up by Bluetooth and Wi-Fi, as I told you. So you may not find a free frequency range to use. Okay, but if your application is very small, say you're using only one or two microphones, then it's okay. But if the moment you start getting into pro use, that you're using it for concerts and you're using multiple microphones on stage, then you should not go into the 2.4 gigahertz. You go in the low frequency range between 300 to 700 megahertz. Okay, is that very clear?
Yes, sir.
Because wireless technology is not a foolproof technology. It depends upon like how well it is monitored, how well it is coordinated. Okay, so usually what happens is, like, especially when camera guys and all are using, they'll get their wireless systems and they'll switch it on, they'll start using it without checking whether the frequency available is free or no. And then what happens is you start getting dropouts, you start getting noise, and then we try to fix it in the post-production. Okay, so whenever, even as on location guys, whoever are going to who are on location sound guys, you need to make sure that you're looking out for free frequencies and tuning your wireless systems to those free frequencies. And through the entire course of working, you need to keep monitoring and checking out if you're losing frequency, if you're getting dropouts. If you're getting dropouts, you need to figure out why you're getting dropouts. All right, is it very clear? PSM is basically in-ear monitor systems. PSM 300 is a low band of PSM 1000 is the flagship in the Shure in-ear monitor system. Okay, so let us get back to our presentation. So till now we know what radio frequencies are. We know how they propagate. We know some of their properties. And now we have seen where in the radio spectrum do they lie and which are the frequencies that we use in our country. Is that all clear? So now let's go on to the components of a wireless system. Now any wireless system will have two main components in it. One is the transmitter and the other is the receiver. Okay. The transmitter is the device that is going to take your audio signal and going to modulate it to a radio frequency. Okay, and is going to transmit that. The receiver is a device that will take the radio frequency, demodulate it back into audio frequency, and then give you an XLR or whatever TRS output that will go into your console or into your camera or into whatever system that you're using. Okay, so transmitter, receiver. Clear? you take out one of these guys and your system is incomplete. अगर आपका ट्रांसमीटर होगा तो रिसीवर होना चाहिए, रिसीवर होगा तो ट्रांसमीटर होना चाहिए, otherwise system is incomplete. How do you differentiate between the two? Always a transmitter will have an audio input, receiver will have a audio output. Is that clear? Because why am I telling you this? Like, I'll give you another example. Now if you see these belt packs here, you won't get to know which is the transmitter and which is the receiver. They look pretty much the same unless and until you read behind. पीछे यहाँ पे लिखा है body pack transmitter and it's written here body pack receiver. But by looking at them, how do you come to know? Is on the transmitter you'll always have a mic line input, and on the receiver you'll have an audio output. Okay, I don't know if you can read on the screen on the thing, but there's an audio output here. This is a input. Okay, so just pay attention when you are dealing with these devices, because sometimes they end up looking the same, but the way the job done is quite different. Now let's look into what are types of transmitters. The thing that you see on the screen, you might have all seen it at some point or the other. It's called the handheld transmitter. Okay, the capsule that is grayed out is basically, most of these guys, many of these handheld transmitters, you can interchange the capsules. Like for example, I can take a condenser mic capsule and bolt it onto the G4 transmitter. Okay, so what is the transmitter here? Basically, is the antenna is the small little protrusion that you see on the end is the antenna. You never hold that; you always hold the shaft. Okay, so that is the transmitter which will take your audio frequency that is coming into the microphone, modulate it into a radio frequency, and transmit it across to wherever the receiver is. Okay, this is one kind of transmitter. It's called the handheld transmitter. This is the body pack transmitter, which I just showed you all. The body pack transmitters here. Now, what you see on the screen is Shure. The one I'm holding in my hand is Sennheiser. This is from a camera. Where this is a camera kit. It is used for mostly for broadcast and stuff like that. Not in not in concerts and stuff, because the range is very short. Okay, so these are called body packs or belt packs. Okay, this is a plug-on. You might have seen this. Sometimes news reporters have like an SM58 or something, and they'll have one big device that is plugged onto the SM58 or whatever microphone they're using. These are plug-on transmitters. Okay, so they have an XLR on one side. You plug in whichever microphone you want onto it, and it will give you, it will modulate that audio signal that is coming through the microphone and transmit it as a RF. All right. Some question here. So if two different transmitters and receivers have similar band frequencies, can they be tuned so that it receives? Okay, tuning the transformers and transmitters and receivers, I'll come to it in a bit, because you have to be really careful with that. Okay, this is a IEM transmitter. Okay, this is used in live sound with IEM stand for in-ear monitoring. Okay, when you're having in-ear monitoring systems where the artist will wear a headphone and will connect to a device that looks something like this. Okay, that he'll be connected to the receiver, but we'll have the transmitter with us. The transmitter is going to get taken output from the console and transmitted to the receiver, which will be with the artist. Is that clear? Now this is the G4. This is the latest by Sennheiser. Did you understand all the transmitters? I mean, these are the broadly, these are the kind of transmitters that you'll usually see. If you're a live sound engineer, handheld transmitter, belt pack transmitter, and the IEM transmitter is the one that you'll mostly be working with. If you're into broadcast, if you're doing location sound, that's when you'll be using something like this or something like what I have in my hand here. Okay, mostly these are used for on location sound, but they work on the same technology. Okay, types of receivers. Now receiver is what? It takes the audio signal, takes the RF signal, and then demodulates it back, takes out the audio from the RF and sends it to your headphones or to your console or whatever. Now this is an IEM receiver. Okay, belt pack, because it is called a body pack because it's usually there with the artist, and it is hooked onto the belt or to the clothing of the artist. And then you connect your earphones to it, and you can now monitor whatever the console is sending you wirelessly. All right, this is the body pack. This is a rack-mounted receiver, which will have an external antenna to it. Okay, what you see on top is the front panel, and what you see at the bottom is the back panel. Now mostly these devices come in stereo pairs. So in one rack mounted system, you'll have two receivers. Okay, at least this is a Sennheiser 6000 series. So you'll have, they come in a rack of two. Alright, they can do a lot of things. You have digital outputs for it, you have Dante and stuff, but let's not look at that. Just look that it takes in. It is a 2-channel rack interface. What you see is one half of it. On the back panel, you can see the 2 channels. You can see this RF output A and B. Okay, you can see 2 audio outputs also. This is a peculiar device. This is for instruments. You might have seen guitarists using wireless devices, right? So this can be used for instruments, for wireless, for making guitars wireless, basses wireless, any instrument can be basically made wireless. The left-hand side, you see the cable, which has a TS on one end and a mini XLR on the other end. Okay, that mini XLR will go onto the belt pack, which is the small black thing you see. And on the right, the picture that you see, which has the digit number and the numbers written on it, 11, that basically is going to be where your pedal board is. And you can use this even as a tuner, by the way. They have given an extra feature where you can use this device as a tuner. So you can mute it and you can unmute it. So it is very handy for instrument for a guitarist specifically, for a guitarist or bassist who wants to basically mute his stuff. He can quickly mute it using, he can mute the audio output and not send anything to the console. Okay, so this too is a wireless system. And if you are using this on your stage, you have to take this into consideration as a wireless system as well. All right. So these are the kind of transmitters and receivers you'll be using. Any doubts here?
No.
Anything you guys want to ask me?
No, sir.
All clear?
Yes, sir.
So now you should know that how to distinguish a transmitter from a receiver, because in many cases they look very, very similar. Like one example is here, both of these guys look very similar. Like a IEM transmitter and a microphone receiver will look very similar. So don't get confused between that. Don't get confused between where to connect your antenna to. Okay, which antenna has to go where. You need to know, you need to read on the device, at the same time look at the connections on the device and get to know which is a receiver and which is a transmitter. Now let's look at the accessories. Now some of the accessories are very important, and hopefully Fali will be talking to you in more detail about the accessories, but I'll just hover over them. One of the main accessories is the antenna. Now you see two kind of antennas on your screen. Okay, on the left hand side is one of the fish is a shark fin antenna or a boat paddle antenna. Okay, and the one on the right is called the helical antenna. Okay, now both these, now remember there is polar patterns in RF as well. Okay, they are very similar to the polar patterns in your audio. Okay, so the antennas that you see in front of you, both are unidirectional antennas. Okay, they have forward gain in the sense they are active in one direction only. The one that you see on the right hand side, that has something known as a 360-degree polarization. Now I told you that RF happens only in one direction, right? If we have the electric current flowing in one direction, RF will go perpendicular, right? So if I have two, like a transmitter and receiver, one that if the transmitter is this way and the receiver becomes this way, the receiver is not going to pick up RF. So in order to RF to flow properly without any interference is to make sure that both the transmitter and receiver are in the same orientation. Okay, but if you have an antenna like the helical antenna, it is basically something known as 360-degree polarization. In the sense, if you see that little copper wire that is like a spring inside the plastic that little plastic cylinder, what that does is it makes sure that the RF is going in all directions, and so no matter how the receiver or how the transmitter or receiver is oriented, it will pick up all the RF without any drops. Okay, it'll get a little more clear to when I go a little ahead. But these are antennas. Okay, these are remote mounting options in the sense that they are not mounted on the receiver. Now this that you see in my hand is basically the antenna for this device, for the BLX, is built inside the chassis itself. You don't need an external antenna for this. Okay, but for certain applications like for in-ear monitors and for wireless microphones which we use in live sound, you would need to remote mount the antenna. Now why to remote mount the antenna? I'll tell you in some time. Okay. Secondly, we use coaxial cables with BNC connectors in RF. Okay. Now, coaxial cables with BNC connectors are used by the video guys as well. So you need to be very sure about which cable you're picking up for your use. We use a 50 ohm cable. The video guys will use 75 ohm cables. Okay. The higher the impedance, the more the resistance to the current and the less the signal flow will be. So we use 50 ohm cables, video guys will use 75 ohm cables. So that's one thing you need to keep in mind, because if you're having long runs of cables and we have a very high impedance, then you will have large signal drops as well. All right. These little things that you see on your screen are basically amplifiers. So if at all you have to run very large cable runs, you can attach and you, so there's a way of basically measuring the level, the signal drop. So if the signal drop goes beyond 5 dB, you need to basically have an amplifier, an inline amplifier. So you'll take your whichever RF output connected to the amplifier, and then the amplifier connected to the input of the amplifier, and the output of the amplifier will give you an amplified signal. Now this amplification is not audio amplification. This is RF power amplification. Okay, it is measured in dBm. Okay, someone has asked me whether BNC is used in DTH connections. Yes, BNC is used in DTH connections also, but the impedance might be different. The cable impedance will be slightly different. What we use is 50 ohms. All right, so these are inline amplifiers which you generally use to boost the RF signal. Now, what you see here, if you see this Shure antenna, you'll see a little device that the cable is connected to. That device is an amplifier. Okay. So if you are remote mounting an antenna and you have a long cable run, you do not need to put an external amplifier again. The antenna itself has an amplifier, so it's an active antenna. Okay. There are two kinds of antennas: active antennas, passive antennas. What you see on your screen is an active antenna. Okay. You also get passive antennas. Any doubts here?
No, sir.
All right.
No, sir.
You guys are understanding, right? You guys are getting the sense of it. So whenever I say frequency, I'm not referring to audio frequencies. Just keep that in mind. I'm reinstating it again and again, so you should not get confused. Okay, now let's come to a diversity system. Unfortunately, I don't have a diversity system here. Now, what is a diversity system? Is instead of having one antenna, the receiver will basically use two antennas. Okay, the two antennas now will basically increase the probability of getting clean RF. Like for example, where would I use it? Say for example, I have a microphone on a very large stage. Okay, every antenna is going to have only a certain limit to it. So when you have two antennas, if one antenna is not picking the RF due to some reason, the other antenna will maybe pick it up. Okay, so it's just a redundant system where you have to make sure either one of the antennas are picking up the signal. Now this is one way of this is a very basic, what you see on your screen is a very basic receiver which has two antennas, and you might have even seen it in your Wi-Fi routers, right? They have two antennas and four antennas, and what we do is we keep all of them all straight. Okay, I'll tell you why you should not keep them straight and parallel to each other. Okay, there's a reason why it's always in a V shape. If you've seen very old TVs and all, which used to come with these inbuilt antennas, and those two antennas used to be always put in like a V shape, there's a reason for it. It's not just there for show. Okay, so we'll talk about how to actually use this diversity system a little later, but let's go into RF distribution. Now there are two things: RF distributors and RF combiners. Okay, what RF distributor does is, suppose we have multiple microphones. Okay, we have say 10 microphones on stage. That means if you have 10 microphones, means we'll have 10 receivers as well. Correct? Am I right or wrong?
Yes, sir.
Am I right or wrong? Okay, so 10 microphones means 10 receivers. Always remember, you can have only one transmitter and multiple receivers. You cannot have multiple transmitters transmitting on the same frequency. You can have one transmitter transmitting one frequency, and you can have multiple receivers receiving the same frequency. It is the same with your FM broadcast. Imagine if 5 FM stations had the exact same frequency. How would you know which frequency to choose? Alright, so always there can be one single transmitter that is transmitting on one frequency, and they can have multiple receivers. Okay, it cannot be the other way around. So if you have chosen one frequency, for example, 535 megahertz have chosen, you cannot tune any other transmitter to that frequency. If you tune any other transmitter to that particular frequency, you're going to get a dropout. Is that clear? So what a distributor will do is, if you have, say, 10 microphones, for in this example, let's take 4 microphones. Okay, if you have 4 microphones, you will have 4 receivers as well. Now each of those 4 receivers will require one antenna, correct? But instead of using 4 antennas, we can now use just 2 antennas, because what the distributor will do is, you connect 2 antennas to distributor, broadband antennas. The antennas will have a wide frequency range. You connect them to the distributor. It will pick up all the RF from these 4 microphones, and then it will have shielded, isolated outputs. Each output will go to the particular receiver. So the output of mic number 1 will go to the receiver number 1, 2 will go to receiver number 2, and so on and so forth. Okay, it is basically taking all the RF and distributing it into multiple receivers. Is that clear? Distributor समझ में आया? Because this is distributors, and in live sound, distributors and combiners are very heavily used in all your Bollywood shows. Our life would be very bad if we didn't have the systems, because we use sometimes 10 and 15 wireless system, that is in-ear monitors, and then we have some 5, 6 or 8, 10 microphone systems. If we had to put one antenna for each of them, then our stage would be full of antennas, right? To reduce the count of antennas, to reduce intermodulation, we make sure that we use distributors and combiners. Distributor will take RF from multiple transmitters and give it to multiple receivers, and a combiner will do the opposite. Okay, it will take RF from multiple. It is used for in-ear monitors. Okay, it will take RF output, analog RF output, that is your coaxial cable output, from multiple transmitters, and transmit it to multiple receivers. Okay, in the distributor, what you're taking RF from transmitters, and you're putting it onto coaxial and giving it to receivers. In combiners, what you're doing is, you're taking RF from coaxial and you're transmitting it over to receivers via wireless. Do you get the difference? This picture here will tell you the difference. So on the upper half, you see the distributor system, where you have multiple microphones. You have 2 antennas in diversity, combining all those 4 microphones, and then sending coaxial outputs to your receivers on the right hand side. In the second half below, you have 4 transmitters connected to your combiner via coaxial cable, and then you have 1 antenna which is wirelessly sending that audio signal to your in-ear monitor, or in-ear monitors rather, 4 in-ear monitors. Any doubt here between combiner and distributor?
No, sir.
All clear?
Sir,
Yes.
multiple mics transmit separate signal on separate frequencies.
Yes.
Uh,
Yes.
But I do not understand about that.
So every microphone, you'll have to tune the microphone to one single frequency. ठीक है? अब
Yeah.
FM में क्या करते हो? Every FM station has one frequency, right?
Yes.
In your city, whichever city you're in. So if you have 10 FM stations in your city, you'll have 10 different frequencies, correct?
Yes.
It's the same case with microphones also. If you're using 10 microphones on stage, each of them will be tuned to one frequency. They cannot use the same frequencies. They have to use different frequencies. अब आया समझ में?
Yes. Same with the combiner also.
कंबाइनर में उल्टा है. कंबाइनर क्या करता है? ट्रांसमीटर से कोएक्सियल केबल लेता है और फिर उसको वायरलेसली इन-ईयर मॉनिटर को भेजता है.
Okay.
ठीक है?
Got it.
So
got it, sir.
distributor will take microphone wirelessly into itself and then send coaxial cables to the microphone receivers. Combiner will take coaxial cables from the transmitter and send wirelessly to the in-ear monitor.
Yeah. Yes, sir.
So-
yes, sir. Got it.
So if I have multiple in-ear monitors, say I have 10 artists on stage, okay, I won't put 10. I'll have to use 10 receivers 10 transmitters. Transmitters will be with the artist because they have to listen to themselves. Receiver will be with me as the engineer. It will be with me because I have to send the audio. Now, if I have 10 of them, then what is going to happen is I'll have to use 10 antennas, but 10 antennas will basically create a mess. Okay, there'll be a lot of issues when it comes to interference because I won't have that much space on stage. So what we do is we use combiners. Usually, combiners can take up to 4 signals inside, but you can cascade them and daisy chain them and do a lot of jugaad in it to kind of make sure that a lot of signals are passing through, depending upon how much of frequency the antenna can accommodate. But in this case, let us just think that I have 8 artists on stage. I have to give them 8 in-ear monitors. So instead of using 8 antennas, what I'll do is I'll take 2 combiners, I'll take 4 transmitters, send the RF coaxial output to one combiner. Take another 4 transmitters, send the coaxial output to the combiner. Okay, now my console is going to send the output to the transmitter, whatever mix I do, and the transmitter is going to take all those 8 outputs and going to wirelessly send it to the in-ear monitor. What's happening on the distributor side is if I have 8 artists on stage, they will be using 8 microphones. The microphones will have 8 transmitters in them. I will use 8 receivers to take that audio from the stage into my console. So instead of using 8 receivers separately and 8 antennas, what I'll use 8 receivers, but I'll take a distributor. I'll take only 2 antennas. 2 antennas, why? Diversity ke liye. Okay, 2 antennas per distributor. Wirelessly or stage se audio aayega antenna mein, and all those audios will then come through the coaxial cable. It will come to the receiver, and the receiver will give me an audio output. Simple, or still need one more explanation?
No, sir. Got it.
All good?
Yes, sir.
ठीक है. Now what you see next on your screen is a passive antenna splitter and combiner. Now thing is, like in small applications you can use it. This particular device can be used as a splitter as well as a combiner. An example is given here. Say if you're doing like a setup in an office. Now always remember, okay, RF is not only for stage and not only for concerts and all. It is done in massive offices also, where you have a lot of conferences and all happening. So say suppose you're setting up a conference room for something and you have a lot of wireless microphones, which are boundary microphones, or whatever level microphones and stuff. And you're doing an install and you need to do a diversity install, and your room is very big. So what you can do is, now in this case, what has been done is they have taken 2 diversity fish fin antennas. Okay, each antenna is a diversity antenna. If you notice each antenna has 2 outputs. One output is giving you a dotted line, one output is giving you a solid line. Samajh mein aa raha hai, right? Then what they're doing is they're using 2 splitters. Let us assume that the antenna on the right hand side is antenna A and the antenna on the left hand side is antenna B. All right, let me take out the screen share. So for example, this here is this is antenna B, and this, let us assume, is antenna A. Now antenna A has 2 outputs because they're both diversity antennas, so they'll have 2 outputs. Antenna B also has 2 outputs. Now they have 2 splitters here. So what they do is antenna A का एक output एक splitter में जाएगा, दूसरा output दूसरे splitter में जाएगा. Antenna B का एक output एक splitter में जाएगा, दूसरा output opposite वाले splitter में जाएगा. And then they both will go into the receiver. So what is happening in this case is, no matter how far the antennas are placed from the transmitter, one of these guys is going to always catch the RF. There's not going to be any dropout. Did you understand this whole system that they did? So even when you're planning RF, right, unlike audio where we are concentrating on mixing and stuff, when you're planning RF, it requires a lot of planning and proper laying out of where you're going to put your antennas and where you're going to put your transmitters and how you're going to set the entire system up. You have to also calculate how much of signal drop you'll get depending upon how long of a cable you're using. Is that clear? So for you guys who want to get into installing sound, who are getting into even doing, for example, if you're doing broadcast sound for something like a Big Boss or or one of these things, reality shows, you will have to do all this, because on that kind of a set, all these kind of installs are done, because no matter where those artists are and where those transmitters and receivers are hidden, they have to, because no one wants to see a transmitter or receiver openly on a camera. it will always be hidden. तो आपको smartly आपको पूरा install करना पड़ेगा, नहीं तो क्या हो जाएगा, आपको video तो आएगा पर audio कुछ आएगा नहीं, फिर नहीं तो टूटा हुआ audio आएगा. Does it make sense? Another
Yes, sir.
example would be this. Now the antennas they're using here are wall-mounted antennas. You can mount these on the wall, on the ceiling, on the wall, wherever you have space. Especially used for install applications. Not much used in live sound. They're meant to be installed. That's the reason why they're even colored in beige and white, so they can match the wall paint. So what they've done here, similar thing. They have 4 antennas, and they have 2 splitters here. Okay. So each antenna, one antenna goes into one splitter, another. So each antenna is going into one side of the splitter, and I mean now they're using it as a combiner basically. So each antenna is going into one side of the combiner and goes in, and all of that combines into one receiver. Okay. So this is the way you can use your this splitter cum combiner. You can also take an audio one single transmitter and split it into for 2 antennas. वो भी कर सकते हो. Okay, in this case, they have basically taken multiple antennas and combined them into giving it to one receiver. Is this much clear?
Yes,
Now
sir.
let us understand what happens. Now I am going to explain to you one kind of modulation. There are basically 6 different kind of modulations. 3 of them are analog and 3 of them are digital. Okay, there's phase modulation, frequency modulation, and amplitude modulation. You might have learned this in synthesis. You have done your synthesis, right? Most of you might have. So if you have done some synthesis and stuff, all this is a similar technology. It's just that in synthesis it's used for audio, and here we are using it for RF. So RF systems of 2 kinds. You'll have analog RF systems and digital RF systems. Digital RF systems, the transmission is slightly more complex. The most simple one to understand is analog RF system. Okay. So now what is this FM modulation? For FM modulation, you need 2 things. Number 1 is the carrier frequency. Carrier frequency is the frequency that will carry the audio from one place to another. For example, 98.3 FM. 98.3 is the carrier frequency. Okay. And then is the modulating frequency. That is the audio that we are sending. So whatever songs that FM radio station is sending to you is basically the modulating signals. That is going to modulate the carrier frequency. Now, how it happens is when you play any sound on it, as you go lower in frequency, the carrier signal frequency also drops. And as you go higher in frequency, the carrier signal frequency also increases. Okay, so as you go higher and as the audio frequencies go higher and lower, that way the carrier frequency also will start modulating from a rest frequency. The 98.3 FM is called the rest frequency. Whenever you feed audio to it, what it does is what the modulator will do is it will start saying, okay, higher frequencies, the 98.3 will start at modulating higher frequency, and it will start the frequency start increasing. And as the audio frequency starts going lower, the modulator frequency, the carrier signal also will start going lower in frequency. Okay, are you getting an idea of what this is? This is how basic FM modulation works. How your FM radio works also. That's how they'll take a broadband audio signal and they'll modulate it with that will basically modulate a carrier signal, and that's how it will be transmitted as one frequency across air to reach the receiver, or to reach your car, or to reach your home, or to reach your mobile phone. Is that clear? आया समझ में, or you're confused?
No, yes,
Yes.
sir.
All good? Still
Yes,
with me,
sir.
right?
Yes, sir.
This has nothing to do with mixing and nothing to do with miking and stuff. This is all proper technical stuff. And whatever I'm explaining to you is still basic technical things. It can get way, way, way more complex. Okay, so I'm only going to explain to you FM because that's what is majorly used. Only some digital, like the Sennheiser 6000 series and the Shure Accent Digital, they are going to be used. Instead of sending analog signal, they're going to be transmitting digital data. And the way they do that is slightly different. It's, you can go and check out, it's called, they use basically phase, phase shift key and amplitude shift key, 2 kind of different modulations they use to send digital data across. Okay, so now the power in a wireless system is measured in dBm, in milliwatt. So wherever you read dB on a wireless system, it is not your dBSP or dBV, it is dBm. Remember that it is, you're measuring the power. You're measuring the power of the electromagnetism of the system. Okay, at what power are you transmitting the signal or receiving the signal? So all the amplifier and stuff I spoke about earlier is basically power amplifiers, which are increasing the amplitude of power. Is that clear? So about dB and stuff you have learned, so I'm not going to get into that. Okay, so if you're clear with this, then we'll start getting into how do we deploy these whole things. Now I'm still explaining to you the different components of it. Do you have any doubts here? Do you want me to repeat something? Or you're confused or you're completely lost? If you want to go back somewhere and start afresh, we can do that. We're good? Yes or no? All right, let's go ahead. What are digital modulations? Digital modulation basically, instead of, okay, someone has asked me, what are 6 modulations? Okay, they have 3 analog modulations. They have amplitude modulation, frequency modulation, and phase modulation. Okay, these are mostly used in analog systems. Then in digital system, you have the digital counterpart. You have basically amplitude shift key, phase shift key, and you have frequency shift key. So I'm not getting into that, because if you want to actually learn more about this thing, you can go and take out, Shure has a course in wireless systems. It's a fairly long course, but it's very, very well laid out, and it'll probably take you 2 or 3 days to go through the entire thing. It is a certified course, and in which they'll cover everything what I'm talking about. Everything is covered in more detail there. So if you really are very, very interested in RF, I highly recommend you go and do that. Okay, it's a certified course and it's not very difficult to understand. So they'll talk all about their systems, and they'll basically also show you a lot of stuff with the right gear. So what I'm explaining to you is kind of a very basic thing to get you up to speed with what we are going to do tomorrow. Okay, so RF deployment. So now, first rule of RF, whenever you're setting up any RF system, keep direct line of sight between transmitter and receiver. Now, what is direct line of sight? Means you should not have any obstruction between the transmitter and receiver. Now, if I have my receiver and transmitter, okay, they're at a distance is okay. Okay, to a particular limited distance is fine. But if you have some obstruction, like if there is a concrete wall in between, then this RF transmission is going to get restricted. Okay, there's going to be a drop. So try to keep as much as clean line of control, so line of sight between the transmitter and receiver. Okay, so you remember that human body also absorbs RF. So if at all, for example, this is my transmitter, this is going to have my mic. Okay, and if I mount this transmitter behind on my back, okay, to my belt, and the cameraman has taken this receiver and has kept on his camera and is sitting in front of me. So what's going to happen is my body is going to start absorbing the RF that is transmitted by the transmitter, and I'm going to have a signal drop on the receiver. Why? Because there's a, so if at all the cameraman is sitting in front of me with this receiver, you as an audio guy should try and make sure that there's a direct line of sight between the transmitter and receiver. So what you would do is, instead of mounting it behind, you would just make sure it is there somewhere in front off camera, so that there's a direct line of sight between the transmitter and receiver. Rule number 1, very important. Is that clear? Doesn't matter with anything, even with microphones and stuff, you try not to have any obstruction between. Try to have direct line of sight. Okay. Secondly, the orientation of the antennas. What we spoke about, that the RF is always perpendicular to the electrical field, right? So basically, if you have an electrical current across this, going across the antenna, the RF is perpendicular to it. So now, if I have my receiver and transmitter, my transmitter is on the camera this way, and my receiver is up straight, then what's going to happen? The null side is facing the transmitter. You're going to have a signal drop. Of course, if it is very close, you might have decent amount of signal, but as you start going further away, you start getting a signal drop. Okay, so if your transmitter is set up this way, you make sure that your receiver also is set up this way. don't put a receiver this way, or don't put the transmitter this way, or don't keep it this way also. It's not going to pick up anything. So they need to be parallel. Okay, a little bit angle is still okay, but depending upon the distance, sometimes if you're lucky, things might just work depending upon the surroundings. But don't take that risk. If at all you're putting your transmitter straight, make sure your receiver is straight. If your receiver is put any other direction, make sure that the transmitter is somewhat parallel to it. Because what happens usually with these systems is you get a horseshoe which kind of clamps the receiver. Sorry, this is the receiver, which clamps the receiver this way on the camera, right? And the receiver is clamped this way, and you will have your artist who's wearing the transmitter and who's wearing it on the back. So now we have two things that are bad. One thing is because the transmitter is on the back, the artist is going to absorb a lot of this RF. Secondly, to make things worse, you have also put the receiver perpendicular to the transmitter. So you're going to have all the more signal drop. Okay, so you need to be smart enough, see where you have space to kind of mount these things and make sure that they have direct line of sight and they have a good orientation. Is that clear? Did that make sense to you? Okay, RF is always perpendicular to the, why I'm saying this, because RF is always perpendicular to the flow of electric current. So transmitter receiver need to be in the right orientation. ऐसा नहीं चलेगा, ऐसा नहीं चलेगा, ऐसा नहीं चलेगा, ऐसा ही चाहिए. ठीक है, ऐसा रहेगा तो चलेगा, ऐसा रहेगा तो चलेगा, ये भी चलेगा. This also would work. If you have one ulta and one seedha, it also will work, no problem. Is it making sense?
They should be parallel to each other.
They should be parallel to each other, yeah. As much as possible, parallel to each other. Okay? And also with these things, right, these are very low wattage. The power is comparatively low in these. So they're not meant to be used over large distances, so short distances. So within the short distances, and what is going to happen if you're with multiple, if you're working for broadcast, like for a news channel, and you're working with the camera guy and stuff, and you are using all these things, and you go to cover some event you go to cover. There are probably 100 news channels, and all of them have these. If you don't take proper care in doing these little details, you might not have proper RF. Okay. In those cases, in crowded environments, it's very, very necessary for you to tune the systems properly. Okay, so 3 things. Make sure line of sight is maintained. There is no obstruction between. Make sure that if at all, now these body packs are basically meant to be with the very close proximity to the body. So try to make sure that at least the body pack is somewhere facing the, if it's a transmitter, make sure that the transmitter is somewhere facing the receiver. I mean, it's not possible all the time, but you need to take care of it and you need to keep an eye for it. Okay. Try to make sure that if you are even hiding the body of it, at least the antenna is exposed, because mostly what happens is, especially if you're on a set of a movie and stuff, what they'll do is the person who's in the costume will come and take the transmitter from you, put it inside the clothing of the artist, and then probably put like 3-4 layers of clothing depending upon what the scene is, and then then they'll come out. The antenna and the body pack is completely hidden, so you'll have a drop in RF. If that is the case, then you need to think differently. Maybe not use this kind of a system. Use a kind of a system that can, which has a stronger power output. Okay, so you need to kind of keep these things in mind. Next thing, this slide will tell you this thing. So this is a half-wave dipole antenna. This is basically a 6-inch antenna that usually comes on smaller microphone systems and stuff. You have electrical wave perpendicular, magnetic wave is perpendicular to the electrical wave. So when you're mounting your systems, this is okay. Both are parallel. This is not going to work. Okay. If you're close enough, it may, but as you start going further away, you'll get the signal drop will happen much faster. If it might not be a completely drop out of signal, it might just go, you might start getting noise first, or it might just drop in and out. Okay. ये समझ में आया? Any doubts here? Orientation and what I meant by having them in line of sight. Let me just grab some water. Any doubts? We're all good?
Yes, sir.
Now again, remember, this is not for guys who are only doing a live sound. If by chance you start working in broadcast and you're working on a film set, your life is going to revolve all around RF only and very less of other work. Intermodulation distortion. This is a very important thing that you need to keep in mind. Now, what is intermodulation distortion? Is basically when two frequencies are tuned very close to each other, okay, it will start forming harmonic frequencies, and those harmonic frequencies can interfere with the main frequencies. Okay, mostly it's the third harmonic, not the second harmonic. Second harmonic is if you have frequency 1 and frequency 2. Okay, like for example, in this case, you have two frequencies. The center frequency, that is F1 and F2, are the two frequencies that are very close to each other. What will be the first harmonic is basically the first order harmonics will be F1 plus F2 and F2 minus F1. They'll be usually very far apart. They won't really affect your system. But the third harmonic, which is basically right here, this 2F2 minus F1 and 2F1 minus F2. These are the third harmonic which will get formed and which will start interfering with your main system. Okay, so forget the formula for it, forget everything. You have to make sure that you know that you don't tune two frequencies very close to each other. And how do you do that? Every manufacturer will basically give you a certain group of frequencies. Now, let me, okay, this is the transmitter, the receiver. I don't know if you'll be able to see it on the screen, but I'll read it out to you. What is on this? Someone asked me, how do you tune these frequencies and stuff, right? So every receiver, okay, what you do is anytime you're setting up a new system in a place, say you go to a venue and you're setting up a new system, or you're going to a new set and you're setting up a new RF system, what you do is you first make sure all the transmitters are put off. After you've done your wiring and after you've checked all the power supply everywhere, you make sure that all your transmitters are put on. Now, this here is the transmitter, it is put off. Okay, band there, there's no power. You take one of your receivers, okay, and you can do a scan. Pretty much every brand has some way of scanning, and any professional system will always have a broadband scan. Okay, like this system, probably you won't have it because it's an entry level system. The BLX system is an entry level system, so there are some frequencies that it is tuned to, and it can only work on those frequencies. Anything more than that, less than that, it can't. Whereas this is a professional system for cameras. This will have something where it can scan the frequencies and it can tell you which frequencies to use, which frequencies are free and which are not free. Okay, so on this system, on the Sennheiser G4, okay, you have the menu. Go into the menu. I don't know if you can read, but can you read it? Okay, I've gone into the menu and you scroll down to easy setup. Okay, if you want to note this down, you note any Sennheiser system, doesn't matter if it is your camera system or in-ear monitor system or the wireless mic system, the menu system is the same. So you just take if it's a microphone system, the microphone system will have a rack mounted receiver. You go to that, make sure all the microphones are put off, or they have something called as RF mute. Doesn't matter if it's Shure or Sennheiser. Then you can go into the receiver, and then you basically go, and in Sennheiser you go to easy setup and go to scan new list. When you say scan new list, it will basically start scanning. Now from 470 megahertz to 560 megahertz, it is basically doing a scan. I don't know if you can see it very clearly, but I'll try and see if I can use my iPad camera for this. Okay, where's my camera? There it is. Okay, so if you can see, I don't know if you can see very clearly, but it is doing a scan basically. Can you guys see it? I don't think so. Yeah. So you can see a small bar that is moving. It is basically doing a scan. Now it's checking out which frequencies are free to use. So it will take like 30 seconds. Once that is done, then what's going to happen is, okay, so once that is done, it is almost done now. Okay, now it is telling me bank one, there are 12 free frequencies. So what these manufacturers do is they'll take your entire frequency bands and they'll start making groups, and the groups are made so that there is no intermodulation frequency. So for example, if you take bank 1 will have about 16 frequencies, and each 16 frequencies are far apart from each other. So between those 16 frequencies, there won't be any intermodulation that will going to happen. Okay. So whenever you're setting up a microphone system, make sure that you follow the grouping system of the manufacturer. And until unless very necessary, make your own. Don't try to make your own frequencies for it. Try and follow the grouping system. So go scan on the receiver, check out which frequencies are free where, and try to make sure all the frequencies are tuned in the same group or same bank. Okay. Now in this case, it is telling me group number 1 has 12 frequencies. Free. Group number 2 also has 12 frequencies. Group number 3. So basically, there's no RF problem here. So all the banks are pretty much free. Okay. So I can choose whatever bank, open, and then it will tell me now 1.1 is 470 hertz, 470.1 megahertz. Okay. So I can choose that frequency. I'll say set, and then what I do is I take my receiver, I put the receiver on, and I basically go and start and say sync. And I'll say sync here. And probably I put them in front of each other and they should sync. There you go. They're synced now. Both of them are synced. So if I put a microphone here, this one will pick it up. So this is something that you need to do every day whenever you go to a new place. Even if you're working in a venue that has an installed system, you make sure that before your show starts, you do a frequency scan and make sure that whatever frequencies you're using are clean. Secondly, follow the grouping system of the manufacturer. Did you understand what I meant to say by the grouping system of the manufacturer? अभी जो भी बताइए समझ में आया कि नहीं आया?
Yes, sir.
Anyone else? One person understood. Anyone else? That means others didn't understand over it. Yes or no? Got it. Okay. Someone else has got it. Will RF work in studio recordings? Yeah, they will, but I don't suggest that you use RF in the studio, because it's not a. See, what is happening is, every time the RF is getting modulated, right? The RF is also the audio is also, when they modulate it, the audio is actually compressed. And depending upon the system that you're using, what is the quality of the modulation and demodulation, you might start hearing. That's the reason if you buy very cheap wireless mics, right, they sound really bad. They're very noisy, they're very harsh, because the modulation and demodulation is not very good quality. The compression and decompression, there are two things that happen in it, because we are taking of 20 hertz to 20 kilohertz full band sound. It may be a voice, it may be some music, and we are compressing it to modulate one wave. So the audio has to be compressed. Actually be compressed to make sure that modulates a wave. So that in that compression, then what has happened, that audio is then taken to the receiver and then it is decompressed there. So in that, there is some losses that happen. Now, depending upon how good quality of a system you have, that loss will be less. Okay, that's the reason why digital systems are preferred, because you don't need to do compression, decompression in digital. All the audio is taken, converted into A to D converter, converts to digital first, and then sends a very light digital data to the receiver. And there is no compression and decompression. That's the reason why digital audio over wireless is more cleaner than analog audio over wireless. Okay, not very useful in studio recordings, because in studio recordings you will basically be having very large doors and very thick walls in between, which is not very ideal for RF, unless you're doing a live studio recording where all of the gear is in one room only. Okay. Noise is, yes, less in digital. Digital will not have any noise. The problem with digital is there is latency in it, because the A to D converter in the microphone will take a few microseconds to kind of do the conversion. Okay. But it is not, you cannot hear it, so it doesn't matter. Always remember, digital wireless, at least in live sound, is there only for microphone systems. In-ear systems still work on analog, because in-ear systems the cost would go very high, because you need stereo channels. So you'll need two A to D converters and two D to A converters. Everything is going to double up, and this cost is also going to spiral up. And also there's latency. So there'll be an audible latency, right? So hence, in-ear technology still is on analog, but when it comes to microphone technology, the higher end microphone technology has gone to digital. Is that clear? All good? Open up chat again. Yeah. So did you understand intermodulation? It is basically nothing but formation of harmonic frequencies that can interrupt your RF signal. All right. Now look at this example. Let me make it bigger. There are two microphones which are tuned at 590 and 595. Now they are very far from each other. No problem. It's not going to affect it. But that means you cannot tune any other microphones or in your monitors at 600 megahertz and 585 megahertz. Why? Because the intermodulation frequencies are 600 megahertz and 585 megahertz. Now they've given the calculation there on the side. Okay. Now the scene is, don't worry, when you go to a venue and start setting up, you don't need to calculate all of this stuff, because that's the reason why softwares are given for you, and softwares will do all the job for you. Okay. That's the reason I'm telling you, follow the grouping system of the manufacturer, because all this stuff is taken care of when you're following the groups and the banks of the manufacturer. The only problem arises when you say, for example, this particular system, each bank has 12 frequencies. If at all I need more than that, I'll have to use two groups or two banks. That's when I'll have to just see that, make sure that the bank 2 frequencies don't come close to any of the intermodulating frequencies of bank 1. Is it? And this intermodulation can go exponentially. Now we're talking about 2. If you put 3, you'll have probably another 6 or 7 intermodulation frequencies that are added. And if you have 4, you'll have probably 10 or 15 intermodulation frequencies added. It is a logarithmic scale. It is exponential. It is not like a linear change. Okay. Doubts? All good? Now this is thing we spoke about. We have spoken about one small part of deployment. Let us talk about more things in deployment when you're deploying these systems. Never have antennas parallel to metal surfaces. Now, if this is a metal surface, so my phone is like a small metal surface, okay? You do not want to have the transmitter antenna parallel to it. Okay, why? Because this guy is going to reflect the RF, metal will reflect, and when it reflects it, it might phase cancel with the frequency that is going on. So if it is out of phase, you will have a signal drop. Okay. Whereas if it is perpendicular, it is fine. Parallel, not cool. Perpendicular, okay. Okay? That is one thing you need to keep in mind. When you have two antennas, especially in a diversity system, where you have two antennas, you make sure that they are 6 inches apart at least, because the antennas themselves, around the antenna, there is basically something called the reactive field, okay, which basically the power is very high there. So when you get two of the antennas which are pretty much transmitting the same frequencies or receiving the same frequencies very close to each other, they'll start interacting with each other, and you'll start getting noise and you'll start getting dropouts. So never keep two antennas close to each other. That's the reason why when your Wi-Fi systems, right, you keep the antennas at least about 6 inches, 5 to 6 inches apart from each other. That's the reason why it's made in a V shape and not kept parallel. So if you have one of these massive routers which have 4 antennas on them, make sure that the antennas are about 5 to 6 inches apart from each other. How we do it? By splaying them apart. Same in your systems. When you have a small system like the one I showed you earlier, okay, you make sure that both these antennas are 6 inches apart. If you have amplified antennas like these, where's it gone? Like these antennas need to be at least near about 5 to 6 feet apart. Okay. Now here, what is happening is in the right hand side, the helical antennas, these are very, very directional antennas. Okay, the helical ones are extremely directional. So if you get them slightly closer to each other, it's fine. But then again, you need to see how powerful they are and whether they're giving you any signal drop or not. So when you're putting any powerful antennas, any antennas that are amplified, you make sure that the antennas are at least 6 feet, 5 to 6 feet away from each other, because they're powerful. They have the power is amplified. They have a lot of forward gain. So if they come close to each other, you'll start getting problem in both the signals, whatever you're sending. Okay. RF receiver outputs. So depends upon what receiver output. So basically, if you're using a microphone output, there'll be obviously mic in, because mic out, because there's the preamplifier is at your console, not at your this thing. So, but however, there is a trim control on the transmitter also and on the receiver also. So you can gain stage there as well. Okay. So yeah, when we're using powerful antennas, that you need to keep them at least 6 feet away from each other. Okay. Now in a diversity system, how can I show you a diversity system? When you have two antennas, right? Both the antennas don't need to be in the same orientation. One antenna can be in the other orientation, so that you cover both the planes. Okay. For example, if your fish fin antenna is straight and the diversity antenna, that is the other antenna, can be put on the other side, so that if your transmitter or if your receiver angle moves, it will be picked up by one of the antennas. Is it clear? Did you understand that? Okay. Now I told you not to keep anything in parallel, or else do not keep antennas very close to each other. May there be small antennas or large antennas. Do not keep them very close to each other, because they'll start interacting with each other and you'll start getting dropouts. Okay. Do not keep antennas in a closed space. Like for example, many sound vendors have IEM racks and in-ear monitor racks, and they'll also have wireless mic racks. And what they'll do is they won't invest in buying antennas. They'll use the small antennas that come with the unit itself, and they'll start putting them behind the box and all close to each other. And then you'll think that, okay, why am I not getting signal on stage? Signal is dropping. You'll probably turn the box. Even after you turn the box towards the stage, you're still getting dropouts. Why? It's not because of the orientation of the box or anything. It's just because the antennas are very close to each other. Input antennas, output antennas, all close to each other. So in this case, you need to go and buy remotely mountable antennas. Most of these antennas are not remote mountable. If their antennas are remote mountable, they will be mentioned. These antennas can be remote mounted. So if at all you're putting your in-ear monitors or your wireless microphone, receivers and transmitters in a rack, you make sure that you get remote mountable antennas. Those are the helical antennas, the fish fin antennas. There are different kind of antennas available, and you use them that way. If you're using a very professional high grade system and you're using them at larger concerts or very very high end applications, then it would make sense to kind of get distributors. It would make sense to get remote mountable antennas and very good RF cables. Wireless can drop, yes, due to battery failure also wireless can drop, because why? If the battery power goes low, then it is not the whole circuit is not getting enough power to kind of transmit, so it will drop obviously. So battery management is another topic. We'll come to that a little later. Okay, is it clear? Do not mount antennas close to each other. Do not mount them inside a closed environment like in a rack, in a box, especially close to metal. If you have to mount your receivers and transmitters in a rack, make sure that you get remotely mountable antennas. Do not try to remote mount antennas that come with the system itself. Okay. Perpendicular metal surfaces, okay. Antennas 6 inches, 5 inches apart from each other, okay. If they're powered antennas, active antennas, at least 6 feet. Now, another thing is, whenever you're mounting, if you're in a live show, you'll be using in-ear monitors and you'll be using wireless microphones also. Now remember, in-ear monitors, what happens is, in most cases, you are sending a stereo signal out from your console. Okay, so you have twice the amount of power in a transmitter antenna for a in-ear monitoring system. So never keep the transmitting antenna of an in-ear system behind a receiving antenna of a microphone system, because what's going to happen, the transmitting antenna is going to blast that receiver antenna with RF, which is not necessary, and you will have poor signal coming in from the microphones then. So in that case, you make sure that if you do not have space on your stage, you make sure that you put the in-ear the IEM antenna in front and keep the microphone antenna behind. But then also there has to be some distance between them so that they don't interact with each other. If you have space, then probably space them out properly. If you're working in a corporate environment and you're using these small antennas like these that you then screen, then don't stack up your receivers, and mostly you'll be using wireless mics. So don't stack up your receivers there. You take a table and you kind of space them out, like 6 inches away from each other, so that the antennas do not affect each other. If it's a big problem and they're not giving you that much space, then I would suggest to go for a remotely settable antenna, or you get a distribution system where you can put a couple of antennas for multiple transmitters, receivers. Is that clear? Coming to the last part, at least on the slides, and then there are a couple of things which I'll tell you without slides, is cables. Okay, we do not really think about cables because these BNC cables all look the same, so we don't bother. But the thing is, there are grades of BNC cables also. The grades that we use in RF are RG58 and RG213. Okay, RG58 is basically a lower grade cable, which is okay when you're running small lengths of cables, like maybe a few feet, that is okay. But if you're running large lengths of cable, like if you're running 100 meters, anything close to 100 meters, you go for the higher end cable, because the quality of the cable is going to create a big difference when it comes to long cable runs. Okay, you make sure that you get a 50 ohm cable. If you're running large distances, you get a superior quality cable. Okay, if you're running smaller distances, more inferior quality would do. Like for example, if your transmitter and your antenna, while your IEM antenna is about 2-3 feet apart, fine, you can use that cable. Do not use unnecessarily long cables as well, because the more cable length you have, the more signal drop also is there. Okay, basically every 3 dB loss is roughly every 3 dB M loss is basically roughly half the actual power that you get in the transmission. So don't unnecessarily use large cable runs. Don't unnecessarily use line amplifiers, because the moment you amplify any signal, you're also raising the noise floor up. Okay, so your cable management needs to be very smart and precise. Okay, what did you not understand? Sparsh, you said you did not get it. The dB thing. So basically, every 3 dB loss is basically half the power, roughly half. Okay, so whatever power you're sending, it's a logarithmic scale, right? So every 3 dB loss in dBm is basically half the actual power that you get at the other end of your system. So the thing is, the maximum power loss allowed, the maximum loss of dB allowed is basically around 5 dB. Anything, if you're getting more losses more than 5 dB, you need to put an amplifier there. But the problem is you cannot use more than 2 amplifiers in a line. So that's the reason why using good quality cables is very, very important. Okay, do not use unnecessarily long cables. Say your your microphone receiver rack is in one place and the antennas, you need to place them like 5 feet away. Do not use a 100-meter cable for it. Use a cable that is probably 5 or 6 feet, so that you don't have unnecessary losses in the cable. Okay, because that's just a waste of power. Then any problem, and and what happens is cables are usually not is the last thing you'll go and change, because we don't suspect the most common problem. We'll suspect some issues with the frequency will come. If you start getting losses, the first thing what people go and do is start changing the frequencies. But in many times it happens the frequency is not the problem, it's the problem with the RF cable. Maybe where if the cable is not shielded properly, you start getting interference from outside. Okay, you start getting signal drop. So you need properly shielded, proper shielded, and with coaxial cables with the right impedance on it. For that matter, even the impedance of the connector matters, because they're two different devices, right? You can't use just random any connector, any BNC connector. There are BNC connector, the particular impedance value given to it. So what I would suggest is, if you're buying any system, you go in for quality cables. Belden is a very good company. If at all you are buying Shore systems, Shore makes BNC cables. If you're going for a Sennheiser system, Sennheiser makes BNC cables. If you want large distances, they will give cables that are 100 meters in length. I think that's the max amount of length you get for RF cables for audio. Anything more than that, you need to add a line amplifier and stuff for it. Okay, so let's come to few more deployment things which I would like to talk, and I don't have slides for that. Is basically whenever you're going into a new venue, you make sure that you have, okay, that is basically your BNC cable, sorry, your RF, your coaxial cable, and that's what the cross section looks like. When I was telling you about the quality difference, right? The graph on top is basically RG213, and the graph below is RG58. Now, if you closely look at it, you see the signal loss at about 4. The x-axis is megahertz, that is the frequency. Your y-axis is power loss in dB, in dBm. Okay. Now, at 430 megahertz, if you see, in the RG213, you're getting about -4 dB of a loss. Okay, but in the RG58, the airborne 5, that is the RG58 airborne 5, the red line, at 430, you're getting approximately a -6 dB loss. It's pretty much 2 dB more than thing. So, and 2 dB is a lot when it comes to RF. Okay, that is more than the permissible loss. So you would have to add an amplifier in that. Okay. So this is just an example to show you the differences. So if you're using anything logger, if you want cables for long runs, you make sure that you buy the higher grade cable and not the lower grade cable. And these cables are expensive. That's the reason why people don't want to invest a lot in these cables, because they're expensive. But the reason why they're expensive, because they offer superior quality. Okay, some best practices. First thing I told you, transmitter receiver line of sight required. Okay, avoid holding your antenna, for especially, like, I don't have a handheld microphone here, but what many artists do is they won't hold the shaft of the handheld mic. They'll hold the absolute end where the transmitter antenna is, and once you cover that antenna up, your RF power can drop up to 50%, because your palm is going to absorb all the RF, and then you'll wonder why isn't it transmitting, because the artist is holding the end of the microphone. You're supposed to hold the shaft and not the transmitter antenna. Okay, make sure the flexible antennas of your devices are not bent, are not curled up, are not broken, because if that happens, again you'll have bad quality RF that gets transmitted or received. Okay, whenever possible, try to use diversity receivers, because the diversity receiver is going to increase the chance of you getting a better signal. Okay, in case that you have, like I said, in case you have IEM transmitters or mic receivers, whatever, in a different room, like for example, if you're doing a install at a venue or in an office or whatever, and for some reason you have to put your transmitters and receivers inside a mic closet or inside a equipment room, then make sure that you use remotely mountable antennas, and you mount the antennas in the room where the devices are going to be used, where the wireless devices are going to be used. For example, if you're using in an office situation, any office building would not like to have, any conference room won't like to have all their gear lying around and exposed. So they would want you to install it in a place where you cannot see it. You can install the chassis, okay, in a different room, but you make sure that the antenna is coming to the room where they're using the wireless microphones. Okay, now if they are very particular about the look and feel of stuff, do not use your fish fin antennas and stuff which are usually black in color. You can go for wall mounting antennas. Okay, mount them on the wall, on the ceiling, and they'll pretty much pick up and they'll pretty much be invisible to the, at least they'll get camouflaged with the paint of the wall. Okay, so if you're putting your transmitter receivers in a housing, in some sort of a flight case, something somewhere, you make sure that you're using remotely mountable antennas. Okay, now I showed you the 1/4 wavelength antenna, the small antennas. The reason why you cannot remotely mount them is because they always require the base of the chassis to give them the amplification. Okay, because that is going to reflect. So it is going to increase the power of the signal that is getting coming to the antenna. If you disconnect that, then it might not work as well. That's the reason why it is designed to be made small, so it can be mounted on the chassis, and the chassis is a part of that antenna. Okay, do not disconnect that and think, okay, a chota antenna which is about 4 inches in height, you can go and mount remote mounted. You won't be, because that antenna won't have the output of that antenna. The RF output won't be strong enough to travel through the cable and reach the chassis. So it is meant to be mounted on the chassis itself. Okay. If at all you're setting up antennas far from stage, okay, try to use unidirectional antennas and point them at the stage. Okay. Especially if you're using, like in small clubs and all, where you're using wireless microphones or in-ear monitors, and you do not have space on stage, but you'll put all the antennas at the FOH. You make sure that the antennas are above the heads of the people, okay, at least 6.5 feet in height, so that the people don't absorb the RF. Because if you keep it in line with the people, then you're going to have bad reception. You basically keep it above the heads of the audience, so that it is looking directly at the stage. But as much as possible, keep the antennas on stage itself. Okay. Again, use distributors, combiners if at all you're using large number of IEMs and large number of microphones as well. So that will kind of reduce the amount of antennas you use, and at the same time, it will reduce the possibility of intermodulation happening between the antennas itself.
I have a
All
question.
right. Yeah.
Yeah. So basically, if I'm in a room, it's a conference hall, maybe a bigger one, and if my speaker is going to move from the stage till the back of the room, and if I have only one antenna with me, so how do I place it and where do I place it?
See, the problem here is now it depends upon, first of all, how much of how many people are there in the room. Okay. Now it could be like, you could probably try and place the antenna somewhere in middle of the room, so that no matter where he goes, you pick it up. But again, if it's a directional antenna, then you're not sure where he's going to be. In that case, what I would suggest is you basically get an antenna splitter, the one that I showed you, the passive one, and you install 2 antennas and use the splitter as a combiner, and then put it into your receiver. So you can place one antenna at one end of the room and the other antenna at the other end of the room, and have it come towards the so you basically make a sort of a diversity system that way.
Okay.
That would be the best way to go around it. Because if your speaker is going to move, you don't know where your speaker is going to move and which way he's going to turn around, right? And the more the people in the room, the more the absorption also. So the more further he goes away from the antenna, and if he turns his back towards the antenna is at the other end of the room, you probably will have a drop in RF. So then I would suggest is add one antenna in one end of the room, other antenna other end of the room. Make sure that you're using proper cables and you use a splitter or the passive combiner that you have, and then combine it to one, and then put that into your wireless receiver basically. If you have a diversity capable receiver, then you can basically, instead of putting both the antennas on stage, you can basically put one antenna on stage and one antenna somewhere in the middle of the room as well, looking towards the speaker. And you can, but just make sure that you use the same length of cable, because that is also another problem. Okay, so that's things you can do to avoid your problem. Any other doubts?
Is there a chance of getting jitters if we are using multiple digital transmitters receivers?
No problem, because see, when digital systems, every frequency is encrypted. There's an encryption that happens with every frequency, and only the receiver which is tuned to that frequency can decode that. No other receiver can. Even if it comes close, like Shor systems are very smart. If it comes close, even the analog system, if you have 2 frequencies that are close to each other, I probably Fali will show it to you tomorrow. Like even the QLXD and the Axion system can do it. Like if at all, for example, like let us switch on the system here. If at all I'm using, say, 470.1 megahertz, okay, and say I have tuned a microphone to that, say an Axion system microphone to that, and a reporter comes in with this kind of a wireless system, and he's also tuned to the same frequency. So the Shaw system is smart enough to find out, okay, that other Sennheiser system that's come in is not a part of my system, because the mic transmitter and the receiver have a signal that is encrypted in them. So what it will do is it will block that frequency. It will block the other thing, and it will not let the your RF transmission drop out. So that's how they basically avoid any sort of jitters, any sort of what do you call it, unwanted dropouts. But those systems come at a price. It is difficult to do in analog systems, but yeah, in digital systems, that they are pretty much encrypted, so you won't have any problems that way. Anything else? Cool. So yeah, I mean, these are few things which I wanted to see. I hope I've kind of at least introduced you all to the components. So the main thing is the components of your system, because you don't want to get, if tomorrow if Ali is talking about some component, you don't want to get confused. So you remember what are transmitters, what are receivers, what are antennas, okay, what kind of cables, what kind of, I've shown you a couple of kind of antennas. So I hope that kind of clears, at least gets you introduced to this whole world of RF, because none of you guys have probably done any RF stuff in this entire course. This usually we do it in live sound. So for the guys who are going to do live sound later on with me, we're going to probably touch up on this again. But for the other guys, this is mostly to introduce you to what's happening tomorrow. All this hardware is, what about software? Yes, software is there. Software is basically RF coordination. I spoke about RF coordination, how to scan the frequencies. Software is basically, most of your systems, your pro systems will give you some software which is going to aid you. It's not going to solve all your problems, but it will help you in solving a problem. Like for example, Shore makes wireless workbench, Sennheiser makes wireless system manager. What happens in that is basically it will help you to scan. You can network this system. So basically I can take the best way to use any high-end wireless system is to go and network all of them. All the systems come with Ethernet ports behind, and they can be networked with each other. The Sennheisers can, of course, it has to be brand specific. You cannot network a Sennheiser and Shure together because it just won't work. Sennheisers can be networked with Sennheisers, Shure can be networked with Shures, and then you can put all of the stuff on a wireless Wi-Fi network and monitor it using your iPad, using your laptop, PC, whichever is Wi-Fi enabled. If you do not have a Wi-Fi network, you can use a network switch and take an Ethernet cable and connect it to your computer. So what do these softwares help you in doing? All your scanning is supposed to be done on the receiver itself. Okay. But what happens with, like, if at all you invest in some of the Shores, there's a servo, I forgot what's the model of it. Basically, there's a system that it basically is a servo for frequencies. So if you have that, if you buy that, that itself is about like £1.5 lakh, 3 lakh rupees, I think. Let me just Google that and show it to you quite quickly. So all your scanning is supposed to be done with your receivers. Okay, transmitters don't do scanning. Why you do scanning with receivers is because any frequencies the receiver is going to try and go and receive it. Now whether it depends upon whether the receiver is tuned to it or not, and it'll demodulate it. But if it's not tuned, it'll scan everything and it can tell you what frequency is free and what is not free. Okay, there are a few things you need to keep in mind though. Like, just let me open the Accent Digital and let me share the screen. So if you're on a Shore system, SLXT Advanced, so they have some systems which are quite cool. So this thing I see on top, the AXT 6000, this device right on top, it basically it's a server sort of a thing. But what it does is, if you have that with you, that itself is basically like, I think, close to 3.5 lakhs. Here it is, the Spectrum Manager. So what it does is you can network this. The best thing about Shore is that, each of these devices, especially in the Accent or even the QLXD, all of them have 2 network ports, and they can be basically they have a network switch inbuilt. Now, what is a network switch? If you take a router and you see there is one place where you connect to Ethernet, that is the modem, and the other places are just network switches. You get 4 network switches there. So you can do LAN connections through those. You can do that also on the Shore systems. Sennheisers unfortunately don't have those. You have to use an external network switch. But you can network all these devices together, and you can put them on a Wi-Fi network. and then you can monitor it using wireless workbench. So now the cool thing about this AXT600, sorry, the AXT600 is that once you have this online, you don't need a receiver to do the scanning. You can just use this device to do the scanning through the antennas. Okay, you can do the scanning, and all the data can be then sent across to your transmitters and receivers using infrared. Like you take your microphones, and because all the transmitters and receivers will be linked to this wired network, so all the data will go there, all the frequency data will be distributed there, and then you just have to go and link the individual belt packs or the microphones to their particular transmitters or receivers. So that's how the software will help you. Sennheiser, what you can do is you can basically, even on shore, you can name the devices, like each and everything. You can change the name. You can go inside and on the screen, you can basically change the name of the device. You can change the name. You can lock it. You can do processing on it. These people give you basic high pass filters and limiters and stuff. You can do all that processing through the software. Also, what can be done is if at all you're using like maybe Shure microphones and Sennheiser in-ears, okay, then what you can do is you can actually go and do a scan for common both of them. Like basically you can do a scan using the Shure system, and it will show you which frequencies are free, and then you can manually go and put it into the Sennheiser system. Okay, but that is a little bit of a long process. It's better if you have a Shure system, Sennheiser system, do separate scan for Shure. Once you've done the scan for Shure, then make sure that all the devices, yes, once you do a scanning and once your devices are linked to each other, keep them on, because the moment they go off, the link breaks and those frequencies become free to be picked up by anyone else. So if at all, like for example, I'm using Shure microphones and Sennheiser in-ears, once I've synced my microphones, once the RF is coordinated for them, I'll keep those microphones on and then go and do the scan on the in-ear monitoring system. Now, though the frequency ranges might be different and stuff, just to be sure, I'll make sure that my microphones are kept on, and then I'll do the frequency scan for the in-ear monitoring systems. Once your scans are complete, once you have linked it, make sure that everything is on all the time. Okay, which gets me to battery management. Most of the manufacturers ask you to use alkaline batteries, but you can also use rechargeable batteries. But the thing, what they say, the rechargeable batteries have a lower voltage, so they might not power the system as well. But if at all you're using rechargeable batteries, you have to make sure that you are keeping an eye on the battery. So, all your Shure Accent series, QLXT series, your 6000 series, and on Sennheiser, they all have a meter that shows you the amount of battery. The moment you feel the battery is going low, you have to change it. Don't wait for the last minute. ऐसा नहीं कि last का 1 घंटे आएगा फिर मैं change करूँगा. At least Shure system will tell you how many hours and minutes are left till the battery dies out completely. Sennheiser will give you bars. Okay, so you just check out how many bars are there, and then you make sure the batteries are changed. Now someone has said AVB network. AVB network, yes, you can use Dante and AVB on certain systems, wherein you don't need to, you can get the entire wireless network on a Dante system with Soundcraft consoles. What happens is you can basically get all the battery information, the frequency information on the channel strip of your screen. Okay, so that's how you can use the systems on Dante and stuff like that. I'm not sure if you can directly get audio from that, but at least for information, you can get all the information about the wireless system on your screen, at least when it comes to Soundcraft consoles. Other consoles, I'm not really sure. Any other doubts? Anything you didn't understand? Anything that went completely bouncer? So if you want me to repeat something, I can repeat stuff for you. We're all good? Yes or no? All right. Any other doubts we have regarding any of these things, regarding cables or regarding transmitters? Okay, I told you this, right? This guy basically has a antenna built into the chassis only. Okay. So this is the BLX system, which we have in college. If you're using it for how much role does room surfaces play? See, mostly room surfaces depend upon how smooth the surface is. If there's mostly the walls and all will absorb the RF, but in if very rare scenarios, they could reflect also. So, but The best way to kind of take care of things is that you make sure that your antennas are not facing the wall; they're kind of facing towards where the transmitters are. Okay, so you're getting direct line of sight. But how many of you all have seen, Boys on Amazon Prime? I know it's a little off topic, but I think it's in the first episode or something where they take, what's the guy's name? The superhero, and they basically lock him up in a basement, and then they make sure that because each of these guys have a transmitting chip inside them, what they do is translucent. They basically lock him up in the basement, and they line up the entire basement with aluminum sheet, right? For those of you guys who've seen that series. Now, why do they line up the room with aluminum sheets? Is because the aluminum sheets are going to reflect the RF, and that's how it's going to be. The RF will not leave the room, and when the RF doesn't leave the room, the receiver won't pick it up, so they won't know its location. So that's the reason why what happens that when you go into like old structures which have very thick walls, all of a sudden you start losing phone network. Why? Because those walls start absorbing, and they don't let the walls are so thick that they don't let the RF through at all. That's the reason why you start losing phone network and all that stuff. So these are basically simple physics, which is common across everywhere wherever you use RF. Okay, anything else? Any other doubts that you have? So I'm guessing most of you guys will also attend tomorrow, because I'm sure Fali will go a little more deeper into this. I'm just trying to give you an introduction to this. But please keep it more interactive than what we have today. So do ask your questions. And to give you so Fali is a mixing engineer also, but please don't try and keep your questions less of mixing and more of RF, because it's an RF workshop. Though I'm sure he'll not say no to your question, but I'm just telling you guys right now, try and keep your questions more towards RF and less towards mixing. Okay, less mixing, less consoles, less microphones. Concentrate on RF. Noted? Clear? Mandar, I am done. So
Yeah, we can stop it.
yeah.